Hello, it's Justice here. Welcome back to my YouTube channel. Today we're going to be solving Leetcode number 5, longest palindromic substring. So given a string S, we're going to return the longest palindromic substring in S. So what is a palindrome? So a palindrome is, in this case, is going to be a string that reads the same forwards and backwards. So let's take a look at this example of a palindrome. So we can have A, let's have B, and let's have A. So we're going to see that this actually does read the same forwards and backwards, and how are we going to prove that true? So we're going to take a center value of this palindrome. So the center value is this B value is pretty clear here. It's the center of the palindrome or this string. And we're going to take a look at the left and right side of the center point, and we can treat the center point like a mirror, and we're going to see if these sides are symmetric. So we see we have one character A on this left side and we have one character A on this right side that are both identical. So this is symmetrical from the center. So we know that this is a palindrome. But if we've seen, this was pretty easy to find because this is actually an odd palindrome. So odd. Let's take a look at another example here. So let's say we have an even palindrome. So we have A, B, B, and A. So see, it's even because it's of length 4, and we're going to say, okay, we need to find some symmetry from our center point. But what is going to be our center point in this example? Is our center point going to be this B? Is our center point going to be this B? In this case, for even palindromes, we can say our center point is both of these together, because if we can look at this, if we can treat both of these characters as one mirror, and we look at the left and right sides of this mirror, we can find that this is also symmetrical. So we can find that there's one character A here and another character A here. So in this case, this is an even palindrome. So we have two different cases. In an odd case, it's pretty easy. We can find the center, and the center is going to be one character, and we can just use one character as our center value. But in even palindromes, we need to keep into account that we can have two different characters that are side by side being treated as one mirror and just looking from the left and right sides of that palindrome. So this input string S here is going to have multiple different palindromes within it. It can have multiple, it can have no palindromes in it, but it can have odd or even palindromes in it. We just need to make sure that we return the longest palindrome, whether it being even or odd, in our input string S. So let's take a look at both of the examples and walk through them. Okay, so let's take a look at this first example with the input string S here. So we're going to check for all even and odd possible palindromes in the substring. So let's start with B here. And for odd palindromes, we know we're only going to be checking the first character as our center. So first character as our center here, we're going to treat this as a middle value, and we're going to check our left and right side. So we can check our left and our right side, and we see that they don't equal each other because there's nothing on this side, and this side has a character A. So those two don't match, so we know that that is not a palindrome. So now we're also going to check for even palindromes, and remember, we check for even palindromes, our window is going to be larger than for odd ones. So we're going to say our window is going to fit 2 characters, or large enough to fit 2 characters. So we're going to check, do the characters in our even window equal each other? No, so this can actually not be a mirror, or because we see that both values here don't equal each other, so that's not even going to be an even palindromic solution. Okay, so now let's move both of our windows. So we already checked that, so we're going to check A for our odd, and then we're going to check A and B for our even. Okay, but now let's first check for an odd palindrome. So in our odd palindrome, we're going to remember that we keep the A as a mirror value. So we're going to say, okay, let's check the left and right sides of A. So we check the left, it's going to be B. The right is going to be B. So cool, we found one of the valid palindromes, but we keep going. So now we're going to see, okay, if we keep going right and keep going left on the left side, do they equal? No, they don't. So here, there's no value here, and here we have an A. So we know that the longest palindrome that we can get from this A value is going to be of this length here with the B and the B. So in that case, we found one palindrome in our solution, and here we're going to say that that is of length 3 because we have 3 characters in it. Cool. Now let's take a look at the even palindrome subsequence. So we're going to see here in this even palindrome, is the mirror value equal to each other? No, they're not, because we see an A and a B here. Those are not equal to each other, so we know that we don't even need to check for what mirrors on the left and right sides, because the 2 values that we're accounting for our even substring are not even equal to each other. So we're going to keep that moving. Okay, so I'm going to bring this over. So we're going to bring this over here. We're going to check that, and then we're also going to bring our even window over here. So with that being said, we're going to check from our odd first. So we're going to say, okay, we have B here. So we're going to check its left and right sides, treating B as the mirror. Left and right sides equal each other, so we're good. We found one possible palindrome, but we're going to keep checking with its left and right pointers. We're going to check left and right. We see a B here and a D here, so those 2 don't equal. So we know that the longest palindrome we found was within this side from B. So we can say we found another palindrome here. And this one is of length 3 because we have 3 characters. And then when we check the even value here, we see B and A don't match, so we don't even need to check for that. We can keep moving our pointers. We check here, and we're going to check this window for our odd and this window for our even. So we see the A value here. We treat that A and the odd as a mirror, and we're going to check its left and right values. So left is going to be B, right is going to be D. Those 2 do not equal each other, so we know that there is no palindrome starting from this character A that is going to be odd. Now we check our blue, which is going to denote the even palindromes. We see A and D don't even match each other. So with A and D not even matching each other, we know we don't even have any possible solution, so we can move forward. We check D here, and there's going to be no more even values left because there's not any more characters valid enough to have 2 different characters to check from. So we're going to just check this D value and see if there's any odd palindromes that we can find from D. So let's go here, check any odd palindromes that we can find from D, and we see that we check the left side, this is A, the right side, there's no value here, and if we compare those, then there's nothing left. So that is not a solution as well. So with that being the case, when we went through the whole input string S here, we found 2 odd palindromes of length 3, and which one was BAB and then another was ABA. And if you see out here in the output, we can either output BAB or ABA because we want to return the longest palindrome, and they're both equal length of 3. Well, the longest palindromes are of equal length 3, so we can return either one in this example. So I'm going to clean this up, and we're going to take a look at example number 2. Okay, so I'm going to go through this example a lot quicker as we did a lot of the intuition and steps in the first example. So first we're just going to start with the even palindrome checks and basically checking 2 characters. First we need to make sure the 2 characters in the window equal each other. If they do, then we know we found at least one even palindrome within the substring S. So here we see these C and B characters do not equal each other, so this is not even a possible even palindrome. Here, yes, we do find two characters in our input string that do equal each other in our window, and we just check the left and right values of the mirror and see if it's symmetric. This is actually not symmetric, but we know we at least have one solution because we have 2 characters in the window that equal each other. So BB reads the same forwards and backwards. So with that being the case, we know we have one solution here of BB, and we know that's of length 2. Okay. Now we're just going to keep moving our window. So we move our even window here. So this even window is going to say BD. These 2 do not equal each other. We can keep moving it. We see B and nothing, D and nothing. That doesn't equate to anything in this example. So we only found one even character here, one even palindrome, and it's of length 2. So now let's check for odd palindromes. So odd palindromes, we know the middle center value is only going to be one character, so we just need to check the left and right values. So left is nothing, right is B. We know that those two don't mirror each other, so we can keep going. Here, left and right do not equal. We see C and B, they don't even equal, so we know at character B, we don't have any odd palindromes. This character B, same thing, B and D don't equal each other, and then this last character D here, you can see B, compare that on the right side with nothing. We know that we have no odd palindromes in this input string S. So we only found one palindrome in the input string S, and that was of length 2. So we just return that palindrome back. So we return our output BB, which is the two characters within our even palindrome. So let's go into the coding. Okay, so let's get into the code here. So first we're going to start with our base cases that we can return. So we know if there's no input string S, so input string is empty or the length of the string is just 1 or less than or equal to 1, we know we can just return whatever S is. Because if S is empty, we're just going to return an empty string, or if S is just one character, we can just return that one character because we know that one character would be the longest substring of that. So we're going to keep track of our results, and this is what we're going to return inevitably. So now we're going to loop through all of our characters in our input string S. So for I in range S. And we're going to be checking for odd and even palindromes. And when we check for odd and even palindromes, remember we need to check at the center and expand outwards. So we're going to have a function called expand at center. And for odd palindromes, we know that the center value is going to be at these same points. And then for even palindromes, we're going to call that expand at center function. And we know that for even palindromes, our center value is actually going to be 2 characters. So it's going to be I and then the character after I, which is I plus 1. Cool. And then we're just going to update our result to be the maximum of itself, the odd palindrome that we found, and the even palindrome that we found, if we found any. And that is going to be checked by the length of all these strings. And at the end, when we go through all the characters in S, our result is going to hold the maximum value or the maximum palindrome. So we're just going to return the results. Cool. So now let's define our expand at center function that we were talking about. So expand at center. We have our left and right pointers for our middle value that we're going to expand from. And we're going to make sure that that's in bounds. So while left is greater than or equal to 0 and the right is less than length of S. And while the left and right values are mirroring each other, are symmetrical, we're going to be updating our window, expanding our window. So when we exit out of this, that means that we're at 2 characters that don't mirror each other and they don't equal each other. So we need to return the string of the previous values, because these are both left and right pointers are going to both be at places that are excluded from our palindrome. So we need to update the left to be at left plus 1. And then we can go up to right, because slicing in Python, we actually go up to, but we don't include this right variable, so we don't have to do right minus 1. This would already just do that for us because it's not including this right variable. And yeah, that's all the code. It's pretty simple there with the coding solution. As I said, this is pretty quick too. This one is going to be for time complexity. This is going to be O of n squared. This is because for every character in S, we're at most going to be checking all the values in our input string S. And then for space, it's going to be O of 1. Constant space because we did not initialize any extra data structures. So I do a lot of Leetcode problems on this channel. I do a lot of things on this channel as well. So make sure to subscribe for more solutions in the future, and feel free to comment for any other questions you would like me to solve. Thank you, and I'll see you in the next video.